Hello. Today we have problem 15.1, number 7. The grade level that I chose to teach this problem at is 7th grade. The Common Core State Standard that I chose is from a 7th grade level. The Common Core State Standard says, use random sampling to draw inferences about a population. Understand that statistics can be used to gain information about a population by examining a sample of that population. Generalizations about a population from a sample are valid only if the sample is representative of that population. Understand that random sampling tends to produce representative samples and support valid inferences. The problem that we have today says, at a factory that produces doorknobs, 1,500 doorknobs have just been produced. To check the quality of these doorknobs, a random sample of 100 doorknobs is selected to test for defects. Of these 100 doorknobs, 2 were found to be defective. Based on the results, what is the best estimate you can give for the number of defective doorknobs among the 1,500? Solve the problem in 3 different ways, explaining your reasoning in each case. For starters, we need to know what a population, a sample, is. Well, we've learned that a population is all members of a specified group. And we've also learned that a sample is usually less than the population and is a subset of the population. A random sample is when you randomly choose the sample from the population. In our problem, the random sample is the 100 doorknobs that were selected for testing, and the population is the 1,500 doorknobs that were made at this factory. To begin, we need to make a diagram or a drawing to see what's going on so we can understand the problem. 1,500 doorknobs is 1,500 doorknobs. So our full population is 1,500. If 100 doorknobs were selected at random from this population, so let's say 10 were chosen from here, 10 were chosen from here, 20 were chosen from here, 5 were chosen from here, 15 were chosen from here, so on and so forth, then we get the 100 doorknobs that were randomly sampled. Out of these 100 sampled doorknobs, we found 2 that were defective. So now that we have a picture, we must begin solving the problem. One way to solve this problem is through proportions. If we know that 2 out of the 100 doorknobs that were tested are defective, and because we know that there are 1,500 total, we can set up a proportion like so. X over 1,500 equals 2 over 100. This is proportional because it's random sampling, and as the Common Core State Standard says, generalizations about a population from a sample are valid only if the sample is representative of that population. And because our 100 doorknobs is representative of the total, we know that this proportion will work. We need to cross multiply to set up an equation. So 100 times x gives us 100x. And 1,500 times 2 gives us 3,000. Now we have an equation that we can solve. 3,000 doorknobs divided by 100 will make it so that the exponent is on one side and everything else is on the other. So x equals 3,000 divided by 100. 3,000 divided by 100 is 30. So we then know that out of the total population, 30 doorknobs will be dysfunctional. And what do we always have to do when we write down our answer? Does anybody know? Can anybody find out what I did wrong here? That's right. I did not give units. So it's important to give units because what if we thought this was apples? How do we know that this is doorknobs? We need to give units because once you get into higher math, it's crucial to know what is what. Alrighty, so this means that there are 30 doorknobs that will be estimated to be dysfunctional out of the total 1,500 doorknobs that were made. Great, we know this is proportional. We know that this is representative of the total population from our sample size. What's another way we could solve this problem? Well, a second way to solve this problem is through percentages. Because we know that 2 of the 100 doorknobs that were sampled and tested were dysfunctional, we then know that 2% or 2 over 100 doorknobs are the estimated amount of doorknobs to be dysfunctional. We can multiply our total doorknobs by the percent dysfunctional to find out how many of the total doorknobs will be dysfunctional. 1,500 doorknobs times 2% or 0.02 will give us 30 doorknobs. Once again, we know that this is proportional and, like the Common Core state standard says, we know it's a valid generalization and inference about the population because the sample is representative of the population. So we are spot on. Lastly, another way to solve this is to find how many groups there are and multiply by how many are dysfunctional. This can be done by dividing 1,500 by our sample. So we would have to sample the population 15 times to find all of the dysfunctional doorknobs. And because we know that from one group of sampling that we found 2. So 15 trials times 2 doorknobs from the first trial that are defective will give us 30 doorknobs. And once again, because it's proportional, we know that we're all good. All right, let's try a sample problem. If we know that at a light bulb factory, 1,600 light bulbs are made in an hour. From that hour's light bulbs, 150 light bulbs are tested, and 5 are found to be defective. How many of the total light bulbs will be defective? So what I want you guys to do is to pause the video right here, solve the problem, and once you're happy with an answer, come back and we'll see if you got it right. All right, welcome back. So if our total amount of light bulbs made in that hour is 1,600 and sampled are 150, of those light bulbs sampled, we find 5 defective. I'm going to set up a proportion. X over 1,600 equals 5 over 150. We cross multiply to set up an equation, which gets us 150x equals 8,000. Dividing so that we have x on one side and everything else on the other gets us x equals 53 light bulbs. Thank you so much for listening and paying attention. And if you have any questions, please let me know. Good work today, guys.